Top 30 Rare Gemstones Almost Thrown Away. Have you ever wondered how many priceless treasures have been thrown away simply because no one recognized them? The truth is, more than you think around the world, people have tossed out or sold off stones worth tens of thousands, even millions of dollars, because they looked ordinary. Some were picked up in backyards, found on hiking trails, or lying in the dirt, then sold for a few dollars, used as doorstops, or literally thrown into the trash. In this video, we're diving into the top 30 rare gemstones that were almost thrown away. Each one carries a story that's unbelievable. A man who kicked a rock worth more than his car. A woman who kept a gemstone in a drawer for decades without knowing its value. And stones so rare that experts were shocked they even existed. If you think you know what a valuable gemstone looks like, think again. By the end of this video, you'll never look at a simple stone the same way ever again. Ranked 30th. Oregon Sunstone. Across the basalt fields of south-central Oregon, mine workers once pushed aside pale fragments of feldspar, chalk-colored chips scattered among volcanic rubble. Nothing about these stones suggested value. No clarity, no fire, no hint that light could ever move inside them. They sat in waste piles for years, overlooked as the most ordinary pieces of a landscape shaped by ancient lava. But within certain fragments, something lay hidden beneath the dust. A quiet architecture of copper platelets arranged in microscopic layers. Under the right slant of sunlight, these thin metallic sheets awakened, sending flashes of ember gold and rose across the crystal's interior. Not surface shimmer, not polish, but a glow rising from the stone's core, as if a buried ember had been sleeping inside the feldspar since the day magma released it. The phenomenon is rare even among sunstones. Native copper suspended in transparent labradorite, locked in place during a moment of cooling so precise that temperature and pressure aligned for only a breath of geological time. Most mines never experience it. Oregon does, and nowhere else does the shimmer strike with such depth. Workers who once swept these pieces into discard heaps later returned, realizing the stones they had ignored held a phenomenon unseen in common feldspar. Light behaving like metal, color unfolding only when the Earth's rotation placed the sun at a perfect angle, a beauty hidden not by distance, but by misunderstanding. Oregon Sunstone revealed itself quietly. Not through a spectacular discovery, but through a shift in perception. A dusty shard lifted from a waste pile, turned slowly in the light, and suddenly transformed into a mineral that carried the warmth of a setting sun inside its lattice. A gemstone almost thrown away until illumination exposed what had been there all along. Ranked 29th. Blue Rose Quartz. Miners once pushed aside cloudy quartz blocks, assuming the faint blue haze inside was an imperfection. Under magnification, a different truth appeared. Microscopic dumortierite fibers arranged in precise parallel networks, each aligned with near mathematical discipline. The blue was not surface stain, but crystallographic order frozen in silica. A stone dismissed for lacking clarity became a study in perfect internal architecture. Beauty born not from brilliance, but from precision under polarized light. These fibers revealed a structural precision, rare even among well-studied silicates. Parallel lattices, intersecting at consistent angles, forming a network as deliberate as the grain of fine wood, but carved by geological time rather than tools. The blue color was not paint, not stain, not impurity. It was the visible echo of a crystallographic pattern arranged millions of years earlier, when silica gel and aluminum-rich fluids cooled at a pace slow enough to allow alignment, yet fast enough to trap the fibers in perfect suspension. Only when a gemologist examined one of the discarded blocks under magnification did the truth emerge. The soft blue was not surface haze, but internal architecture, a design held together with mathematical precision. The realization transformed a pile of misclassified rubble into a discovery. A stone judged too cloudy became a study in structural choreography. A fragment dismissed as flawed quartz revealed a beauty dependent not on transparency, but on the accuracy of its internal pattern. Blue Rose Quartz was nearly lost to misidentification, its elegance hidden in layers so subtle that only a calibrated light could expose them. What seemed dull became a record of perfect alignment. A mineral whose value lies not in brilliance, but in the immaculate precision of the fibers that define its blue. Ranked 28th, Ajwat Phantom Quartz. In South Africa's copper fields, stained quartz fragments were thrown into tailings, believed to be contaminated, but each piece preserved a rare geological sequence. Quartz forming, a surge of copper-rich fluid, painting the cavity in blue-greenish white. Then quartz sealing it again, a phantom layer, an ancient breath, trapped inside a new crystal shell. What miners read as impurity was, in truth, a page of Earth's history written twice, long before the first tools touched the ground. A cavity in the host rock filled with silica-rich water. Quartz began to grow, sealing the chamber with its first layer of transparency. Then, in a moment measured not in minutes but in mineral ages, copper-bearing fluids entered the void. A jwite, a hydrated copper silicate, precipitated inside, tinting the cavity with its unmistakable blue-green glow. But the process did not end there. Silica returned, closing the chamber once again. Quartz continued its slow ascent, trapping the ajwat within a ghostly silhouette, a phantom layer suspended like a memory inside the stone. What resulted was not a simple crystal, but a timeline. Quartz, then ajwat, then quartz again. A sequence preserved with such precision that each phantom reads like a page in the Earth's journal. To the miners who tossed them away, these were stained stones. To geology, they are snapshots of the underground world in motion, a moment when copper, water, and silicate crossed paths in perfect order before sealing themselves into permanence. Ajwata phantom quartz carries the stillness of its final layer, yet inside the phantom remains, a whisper of the chamber that once breathed with fluid and color, a gemstone almost discarded as waste, until its internal history revealed the rare choreography that created it. Ranked 27th, Axonite. Among alpine debris, miners discarded blade-like brown crystals that resembled burnt glass. Yet axonite was nature defying its own rules, a silicate twisting symmetry, bending light into violet, gold, and smoke along planes that seemed too thin to remain intact. Its oddity was mistaken for flaw, but axonite exists precisely because conditions push the mineral lattice to its limits. A gemstone discarded for behaving unlike anything expected. Where most silicates crystallize in orderly, predictable habits, axonite bends the rules. Its iron, aluminum, and calcium atoms assemble into blades so thin they seem almost flexible, catching light in ways no typical mineral should brown becomes violet. Violet becomes smoky gold, and each shift occurs along planes that tilt and twist, as if the stone were folding the spectrum back onto itself. To those who discarded it, this oddity was a flaw. To crystallography, it is the sign of a structure refusing to conform, a lattice stretched to its limits, a geometry that breaks symmetry yet somehow remains stable. Axonite forms only where tectonic pressures, boron-rich fluids, and cooling gradients intersect with improbable precision. Too much heat, and it collapses; too little, and it never forms. For this reason, most mountains hold none. Those that do hide it among rocks, so ordinary that its anomaly goes unnoticed. In the waste piles where it once lay, ignored, axonite held a quiet contradiction, a mineral appearing flawed because it was created by perfection, a stone mistaken for shattered glass, when in truth it was the rare outcome of Earth bending its own rules. Axonite was nearly thrown away because it did not behave as minerals are expected to. Its beauty emerges only when the light meets its twisted geometry, a reminder that some of nature's most remarkable creations reveal themselves not in symmetry, but in defiance. Ranked 26th, London Blue Topaz. Dark ink blue topaz fragments once piled up as waste, too deep in color, too heavy in tone to resemble marketable gems. Later, when laboratories explored irradiation and heating, these neglected pieces transformed into the vivid London blue, now recognized worldwide. A stone once dismissed as damaged became the foundation of an industry shift. Proof that misunderstanding can bury value, and knowledge can resurrect it. The deep blue was not a flaw of nature, but a sign of structural density. Aluminum and fluorine arranged in a lattice capable of holding color in its most saturated form. In their raw state, the stones looked silent and shadowed. Under controlled light, however, the blue revealed a depth closer to ocean trenches than sky. The very trait miners believed made the stones worthless was the trait that would later define them. Decades later, when gem laboratories began experimenting with irradiation and controlled heating, the overlooked material became the foundation of a market transformation. Those near-black fragments, once cast aside, proved uniquely responsive to treatment, yielding the richly saturated London blue tone that would reshape global demand for topaz. The shift was immediate and irreversible. Discard bins became hunting grounds. Waste piles were re-examined. What had once been rejected as burnt stone was now sought for the very intensity that had caused its dismissal. London blue topaz carries the mark of consequence, a gemstone whose fate changed not because its nature shifted, but because human understanding did. A mineral nearly thrown away became a cornerstone of modern gemstone commerce. Its darkness transformed from liability into signature. In every deep blue facet lies a quiet reminder of that reversal. That value can be lost not through scarcity, but through misinterpretation. Ranked 25th, fire agate. Rough, iron-coated nodules littered the desert mines of the Southwest, their surfaces dull as dried mud. Inside, thin layers of iron oxide stacked like microscopic armor, trapping and splitting light into shifting bands of gold, violet, and green. A single polished window revealed the fire hidden beneath the rind. A gemstone nearly discarded for its rough exterior became one of Earth's most intricate displays of internal iridescence. Each layer captured light differently, bending it back in waves that split into gold, green, amber, and violet. Not a polish, not a surface effect, but a phenomenon built from within, where light dives through translucent quartz and ricochets between films thinner than a strand of hair. When a piece was accidentally broken open and polished for inspection, the truth emerged. A blaze of iridescence unlike any other gemstone. A mosaic of color that seemed to breathe as the angle shifted. A fire concealed in stone that outwardly appeared exhausted and dull. Fire agate forms only when silica-rich waters repeatedly deposit over iron in rhythmic pulses. A slow, volcanic heartbeat imprinted through time. Miss a pulse, and the color disappears. Interrupt the rhythm, and the fire never forms. Its brilliance is the result of a fragile sequence that no human hand could recreate. The miners who once discarded these stones could not have known the secret architecture was buried just beneath the rind. Only when lapidaries began cutting into the rough did the concealed layers ignite, revealing an inner landscape of flame-like bands and shimmering contours. A gemstone nearly thrown away became one of the most mesmerizing displays of natural iridescence, a reminder that some treasures hide behind masks of plainness, waiting for a single fracture of polished light to expose the fire they carry inside. Ranked 24th. Grandidierite. Mistaken for ordinary green amphibole, rough grandidierite was once shoveled into rubble heaps. Then a cut fragment exposed a tone both oceanic and aerial, blue-green with a glow that seemed almost internal. The discovery ignited a quiet global pursuit. Collectors combed old pits. Miners reopened abandoned trenches. A stone ignored for decades became an object of obsession, valued not for sparkle but for a color that felt impossible to hold. The stone that had looked opaque from the outside held within its core a color spoken of only in mineralogical records and museum vaults. Word spread quietly at first, then rapidly. Collectors began to scour the same waste heaps miners had walked over for years. Small, overlooked shards vanished from the ground overnight. A mineral once mistaken for construction-grade rock became the obsession of gem hunters who chased the fleeting glow with the same hunger reserved for Paraíba or Kashmir. Sapphire grandidierite's allure lies not in brilliance but in its paradox. Its finest pieces appear almost self-illuminated, yet most rough presents itself as clouded and unremarkable. Only a tiny fraction of material carries the translucent depth that defines a species. The surge in demand had consequences. Artisanal miners returned to revisit pits long considered exhausted. Old rubble became treasure fields. Specimens smaller than a fingernail were traded across continents, guarded in padded envelopes like relics. A gemstone nearly discarded now inspired a global chase. Not because it sparkled, not because it was flawless, but because its rarest shade seemed impossible to hold. As though the sea and the sky had merged into a single color that refused to appear twice, grandidierite transformed from waste to wonder, and in doing so, awakened the kind of longing that turns minerals into legends. Ranked 23rd Larimar. Waves once carried pale blue stones onto Dominican shores, where villagers tossed them back into the sea, thinking they were softened plastic. But these fragments were born from volcanic fractures high in the mountains, shaped by hydrothermal fluids into patterns mirroring Caribbean clouds and shallow waters. Larimar became a cultural emblem, a stone carrying the island's geological and maritime heritage in a single swirling blue. High in the volcanic spine of the island, silica-rich fluids once moved through fractures in basalt, cooling into a mineral later transformed by calcium, copper traces, and the thermal pulse of an ancient hydrothermal system. Layer by layer, the stone adopted patterns that echoed clouds drifting over shallow Caribbean waters. No other mineral captured this interplay of sky and sea with such quiet fidelity. For decades, the connection between the beach-worn fragments and their volcanic source remained unknown. The stones seemed to appear from nowhere, their origin dissolved in folklore. Only when a local artisan cracked open a larger piece did the material reveal its true depth. The swirling blues, the milky white currents, the internal landscape that evoked memories of coastlines long before human memory. Larimar became more than a gemstone. It became a cultural emblem, a link between the island's volcanic past and its maritime identity. Miners climbed steep ravines to retrieve the material once mistaken for debris. Artisans carved it into talismans that carried both the color of ocean shallows and the echo of subterranean heat. A gemstone once thrown back into the tide now anchors the heritage of an entire region, a reminder that legacy can lie hidden in the most unassuming shapes, and that the stones carried by waves may hold stories older than the shoreline itself. Ranked 22nd, Vivianite. Miners found dark, clay-like masses that crumbled in their hands and discarded them. Yet the blackness was not original. It was oxygen's mark. Vivianite forms in airless places as luminous blue-green crystals, only to darken the moment air touches them. Inside cracked pieces, untouched cores still glowed like submerged glass. A gemstone at war with its own exposure. Beautiful, but only until it breathes. It was a reaction, swift, irreversible, and triggered the moment oxygen met their surface. Vivianite is born in environments starved of air. Peat bogs, flooded shafts, rusting iron deposits. In these places, it forms crystals of a pure, translucent blue-green, fragile columns that glow like submerged glass. Yet the instant they leave their oxygen-poor cradle, a transformation begins. The blue deepens. Moments later, it shifts toward indigo. Soon after, it darkens entirely. The surface turning opaque as iron within the crystal oxidizes, a mineral of beauty that cannot survive exposure without changing. Tension embodied at the atomic level. This instability made Vivianite difficult to recognize. By the time many specimens reached the surface, their colors had already vanished, replaced by the appearance of dried clay. Miners, unaware of the metamorphosis unfolding in real time, dismissed them as worthless soil. Only when a collector cracked open a discarded piece did the truth come to light. Inside the blackened shell, untouched by air, the original color still shimmered. A torch-like blue held in perfect preservation, Vivianite lives in conflict with its surroundings. To reveal its beauty is to risk its destruction. To protect it is to seal it away from the world it wishes to illuminate. A gemstone nearly thrown away because it hides its radiance behind the consequences of breathing. Vivianite remains one of nature's most delicate paradoxes, a mineral whose greatest strength is bound to its greatest vulnerability. Ranked 21st, Ma Sit Sit. In Myanmar's jade fields, the brightest stones were often the first to be thrown away. Ma Sit Sit's neon greens and chaotic patterns broke every rule of jade grading, too mottled to trust, too vivid to seem natural. Dealers disagreed on value, cutters hesitated. Only later did gemologists confirm its unique identity, a chromium-rich mosaic formed by metamorphic chaos. A jade reject became a coveted rarity, a stone caught between rejection and desire in a market that never knew how to price it. To the market, inconsistency meant risk, and risk in the jade world was something to be discarded quickly. But the stone that failed jade's expectations carried a different story. Ma Sit Sit is a geological hybrid born from metamorphic turbulence, a convergence of jadeite, cosmochlore, chromite, and other chromium-rich minerals compressed together under immense pressure. Rather than producing uniformity, the Earth created a mosaic, bright green veins that pulse like electrical currents, black splashes shaped by chromium oxides, and swirls of material that reflect the violent forces that forge the region's serpentinite belts. Its irregular beauty defied classification, and that defiance placed it in tension with a market built on rules. Dealers could not agree on how to price it. Some buyers dismissed it entirely. Others suspected it was a jade imitation. For years, pieces of Ma Sit Sit sat in the margins of gemstone commerce, too unusual for mainstream acceptance, too distinctive to be ignored by collectors seeking something that felt unrepeatable. Only when gemologists confirmed its unique mineral identity did the value shift. What had been rejected as jade scrap became a category of its own, rare, recognizable, unmistakable in its neon intensity. Collectors began to pursue the very traits that once condemned it: the chaotic patterns, the chromium-rich glow, the sense that no two specimens could ever match Ma Sit Sit, rose not through clarity or tradition, but through the tension between expectation and reality. A gemstone almost thrown away because it refused to play by the rules of the market that judged it. Ranked 20th, Tafite. For years, a small box of inexpensive spinel sat untouched in a Dublin workshop. Stones destined for practice cuts, bead makers, or the discard drawer. Among them was one lavender gem whose color seemed unremarkable, its surface worn, its value assumed. Then came the revelation. During a routine examination, a subtle optical trait appeared. Double refraction where spinel should show none, a flaw, some thought. But under polarized light, the stone behaved not like a flawed spinel, but like something with a structure unknown to gem cutters of the time. What had been overlooked as common material revealed a new mineral species entirely. A beryllium-bearing magnesium aluminum oxide with a lattice distinct from anything cataloged. A gemstone misidentified not in the ground, but in the quiet of a workshop drawer. The consequences were immediate and profound. Jewelry boxes, old parcels, and forgotten gem bags were re-examined around the world within them. A few misplaced taffites surfaced. Stones once sold for pennies, traded as spinel, or swept aside in mixed lots. Even today, many specimens remain lost, still hiding behind mislabels and assumptions. Taffete's rarity does not come from scarcity alone, but from the simple truth that it looks too ordinary for what it is. No dramatic hue, no blazing fire, just a soft violet masking a revelation in its structure. A gemstone almost thrown away because no one expected the extraordinary to hide inside the familiar. Taffete stands as one of the few minerals whose discovery began not in the earth, but in the moment someone finally looked closer. Ranked 19th, Benituat. Along the remote ridges of San Benito County, miners once shoveled pale, wedge-shaped crystals into gravel piles, pieces too small, too opaque, too ordinary to bother keeping. They paved footpaths with them, letting boots grind over a mineral that would one day be known as one of California's rarest treasures. Yet those discarded fragments carried the signature of a remarkable beginning. Benituat forms only under a geological convergence, so narrow it has been documented in just one major location on Earth. A pocket where hydrothermal fluids, rich in barium, meet cooling volcanic rock, where pressure remains stable, and where temperature drops slow enough for perfect triangular crystals to grow. In that hidden chamber, silica structured itself into delicate pyramids, optically sharp, electrically pure, and ready to trap blue wavelengths with an intensity no sapphire could mimic. When unearthed, the crystals looked pale, even colorless, but exposure to ultraviolet light awakened their true nature. A neon blue glow, sudden and unmistakable, as though the stone remembered the conditions of its birth and responded to them. The miners who built paths from Benetoat gravel could not have seen this. The light required to reveal its beauty was too specific, and the crystals too coated with dust and weathering to show their brilliance. Only when a collector examined a discarded piece under a lamp did the genesis become visible. A blue so vivid it seemed to ignite within the crystal, a shape so precise it could have been drafted by geometry itself. Benetoat is the product of a geological moment that cannot be repeated. Pressure, chemistry, and temperature aligning in a brief interval millions of years ago, long before the ridges were carved by erosion or touched by human hands. A gemstone once crushed underfoot now stands among the rarest minerals recognized by science. A creation born from a perfect and fragile intersection, almost forgotten before its origin could be understood. Ranked 18th. Poudretite. In the Poudret quarry of Quebec, pale pink fragments once gathered in buckets meant for leftover feldspar and calcite. Stones too soft in color, too clouded, too easily dismissed. They were swept aside as routine debris, their muted pastel mistaken for a sign of imperfection rather than identity. But what looked indistinct on the surface concealed a structure of remarkable discipline. Under magnification, Poudretite revealed a trigonal lattice so cleanly ordered that light slipped through it with near mathematical symmetry. Its delicate pink was not the result of heavy impurities, but of trace potassium and boron arranged with extraordinary balance, forming a tone that seemed to hover between transparency and glow. This mineral does not tolerate chaos. If the cooling is too fast, it fractures. If the chemistry deviates by a fraction, the color dissolves. Only under a narrow combination of conditions does the crystal lattice align in the precise geometry required for gem-quality material to appear. At first, no one noticed. The stones lacked the commanding saturation of morganite. They lacked the sparkle of tourmaline. To untrained eyes, they were simply pink unknowns, pushed to the margins, traded in mixed lots, or abandoned on sorting tables. The revelation came only when a mineralogist cut a small fragment and held it to controlled light. A perfectly measured translucence, a subtle birefringence, a hue that refused to deepen or fade, instead remaining constant across every facet. It was the precision of the structure, not its brightness, that made Poudretite rare. When its identity was formally confirmed, collectors revisited the very rubble heaps where miners had discarded it, but most of the early material was already gone, scattered or crushed in the routine flow of the quarry. A gemstone almost thrown away because its beauty whispered instead of shouted, Poudretite stands as proof that rarity sometimes hides not in dramatic color, but in the exactness of the lattice that holds it together. Ranked 17th, Geomeyevite. Across the wind-carved ridges of the Pamir and Namib deserts, miners once gathered pale, glass-like shards from pockets of pegmatite, pieces so similar to quartz that they were tossed into the same barrels without a second look, colorless, understated, lacking obvious fire. Geomeyevite blended quietly into the background of more familiar minerals. Yet inside these unassuming fragments lived the legacy of ancient waters. Geomeyevite forms only when boron-rich fluids move through granitic cavities, at a moment when pressure and cooling align with exquisite timing. Each crystal is a remnant of vanished hydrothermal channels, pathways that once carried mineral-laden waters through fractured rock before drying into silence millions of years ago. Its composition preserves the chemistry of those ancient flows: aluminum, boron, fluoride, elements whispering of an environment long erased from the Earth's surface. For decades, the mineral's identity remained hidden behind the simplicity of its appearance. Quartz overshadowed it, topaz outshone it, miners overlooked it, collectors misclassified it. Entire pockets were crushed for industrial fill because no one believed the clear shards held anything extraordinary. Only when a gemologist examined a discarded crystal under polarized illumination did the truth surface. A subtle pleochroism shifting from icy blue to faint champagne, a clarity that spoke of undisturbed crystallization, a lattice shaped by waters that no longer exist. Jeremejevite is a mineral of memory. It carries with it the imprint of a geologic world that has disappeared, ancient circulation systems frozen into crystal form, echoes of a mineral landscape captured in a transparent relic, a gemstone nearly thrown away because it looked too quiet to matter. Jeremejevite endures as a reminder that some of Earth's deepest histories hide in the stones least likely to be noticed. Rank 16th, cornerapine. In the crushing yards of metamorphic rock deposits, green-brown fragments once moved along conveyor belts toward industrial grinders, material destined for road aggregate, ceramic filler, anything but gemstones. Cornerapine, masked by its muted tones and fibrous textures, passed through these systems unnoticed. To workers, it resembled nothing more than tough, uncooperative stone. But the consequences of that misidentification were immense. When held against the light, not the harsh lamps of sorting benches, but daylight with depth, the mineral revealed its secret, a shifting interplay of green, yellow, and blue that rippled across the crystal like diluted aurora. This pleochroism was the signature of a rare borosilicate lattice stretched by metamorphic heat and pressure, conditions so demanding that only a handful of geological environments could produce it. Where most silicates offer a single dominant hue, cornerapine held several at once, each appearing only when viewed along a different axis of its crystal structure. Its beauty existed in a narrow window of orientation. Turn it slightly, and the colors vanished. This was why miners overlooked it, why cutters ignored it, why the stone flowed into grinding machines without protest. Only when a lapidary paused before processing a batch of rough, catching a glimmer of teal at the edge of a fractured piece, did the re-evaluation begin. The discarded rock, once moments away from pulverization, revealed the nuanced light play that defined the species. And with recognition came consequence. Old tailings were revisited, sorting practices changed. Specimens once deemed worthless became sought after for their rare optical subtlety. Yet the damage was already done. Much of the finest cornerapine had long been crushed into powder, its potential lost in the routines of industrial extraction. A gemstone nearly destroyed by misunderstanding, cornerapine stands as a quiet testament to how easily beauty can be erased. Not by nature, but by the decisions made when no one looks closely. Ranked 15th, musgravite. In the remote Musgrave Ranges of Australia, miners once gathered baskets of spinel, dark, resilient crystals destined for industrial use or low-value sorting. Among them were a few stones with a muted, smoky lilac glow. They looked no different from common spinel rough and were tossed into mixed lots without hesitation, traded by the kilogram, sold for pocket change. Yet buried in those overlooked fragments was a mineral that would ignite one of the quietest obsessions in modern gemology. Musgravite is formed where beryllium, magnesium, and aluminum converge under pressures so intense and cooling so slow that the crystal lattice arranges itself into a structure bordering on improbable. Even in ideal geological conditions, the mineral appears only in trace amounts, thin veins, tiny pockets, particles more often lost than found. For decades, no one knew it had slipped into spinel parcels. Its pleochroism, shifts from steely gray to lavender, was too subtle for hurried eyes, too understated for miners searching for bolder signals. Most pieces were cut, sold, or discarded without ever being recognized. Then came the turning point. A gemologist examining a supposedly ordinary spinel noticed a spectral pattern that should not have existed. Absorption lines pointed to a different chemistry, an identity more elusive, more rare. Testing confirmed it. Musgravite, one of the scarcest gemstones ever documented. What followed was obsession, not spectacle. Collectors scoured old inventories. Dealers opened drawers long forgotten. Rough once sold for pennies was traced, bought back, repurchased at prices unimaginable just years earlier. Every stone, even those barely large enough to facet, became the focus of intense competition in a market that had no supply, no stability, and no guarantee that another deposit would ever be found. Many of the finest early specimens had already vanished, cut into small utilitarian shapes or thrown away entirely. Their rarity was not just geological, it was the direct result of human oversight. Muscovite became a symbol of the pursuit itself, a gemstone whose quiet appearance concealed a value so extreme that collectors chased it in silence, each hoping to find what others had missed. A mineral nearly lost to misclassification became an artifact of obsession, proof that the greatest treasures are sometimes the ones the world ignores for the longest time. Ranked 14. Sherwat. In the vast Siberian plateau, workers once quarried blocks of purple stone they believed were nothing more than tough, decorative filler, material suitable for tiles, building slabs, or construction aggregates. Its swirling patterns looked chaotic, its surface fibrous and uneven. So they cut it into coarse panels, stacked it with masonry, and shipped it away as if it held no story at all. Yet embedded in those discarded blocks was the legacy of an ancient collision between heat and time. Sherwat forms only along a single stretch of the Murun Massif, where limestone met the rising pulse of alkaline magma. Under pressures deep in the crust, the rock did not shatter, it transformed. Silicates unfurled into violet fibers, potassium and calcium blended into a shimmering matrix, and the entire mass recrystallized with a motion that seemed almost fluid. The swirling patterns workers mistook for imperfection were records of this metamorphic dance, frozen at the moment the Earth's crust briefly rearranged itself. Every feathered streak preserved the memory of that geological upheaval. Every lavender fold marked the path of minerals migrating through molten stone. For decades, Sherwat's uniqueness went unnoticed. It lacked the clarity markets prized. It offered no standard gemstone geometry. To an industry seeking uniformity, its wild, fibrous waves looked unruly, too strange to cut, too unpredictable to value. Only when a geologist examined a polished offcut did the mineral reveal its depth. Violet layered over lilac, pearlescent fibers catching light like silk threads, textures shifting as if the stone still carried the motion of its formation. And with recognition came a profound reversal. The building slabs once used for flooring became rarities. Small, rough pieces, once tossed aside, became prized specimens. Sherwat, found nowhere else on Earth, emerged as a geological relic, a monument to a moment of metamorphism that will never occur again. A gemstone nearly relegated to construction waste became the keeper of a vanished landscape, a violet testament to the forces that shaped Siberia long before the first human footsteps touched its ground. Ranked 13th, Petsotaita. Across the gem-bearing hills of Madagascar, miners once collected pale pink crystals they believed were simply morganite, stones too light in tone, too clouded, too fragile to earn more than a passing glance. These pieces were sorted into low-value parcels, mixed into buckets of ordinary beryl, or left in the dust beside the pits. But within these overlooked fragments was a revelation waiting for the right light. Pezzotaite does not share the open hexagonal symmetry of morganite. Its lattice shifts inward, tightening into a trigonal framework that bends light differently, creating a subtle, velvety glow instead of the familiar brilliance. To untrained eyes, that softness looked like imperfection. To crystallography, it was the signature of an entirely separate mineral species. In cross-polarized illumination, the truth surfaced. Faint pleochroic flashes, spectral lines in unexpected positions, and internal zoning that did not match any known beryl. The stone was not a variation, it was an identity hidden inside a familiar shape. Only when a small fragment was tested did its chemistry reveal the difference. Cesium replacing positions where lithium normally resides, a rearrangement so subtle that only a mineral born in extremely specific magma channels could hold it. With that revelation, the story shifted. Pieces once sold in bulk as flawed morganite suddenly became among the rarest pink gemstones on the market. Collectors searched old parcels for forgotten specimens. Dealers revisited tailings where stones had been discarded years before. But most of the early material had already disappeared, lost to misclassification long before its significance was understood. Pezzotaite is a gemstone defined by what was overlooked, a mineral whose softness of color masked a structural truth powerful enough to rewrite its place in gemology. A stone almost thrown away became a revelation, proof that even among familiar shapes, a new identity can lie waiting, undetected until someone finally asked the right question. Ranked at 12th, rhodochrosite stalactites. Deep inside the old silver mines of Argentina and Colorado, miners once broke apart pale, mud-coated cylinders hanging from the ceilings of abandoned tunnels. To them, these formations looked like nothing more than mineral residue, soft pink tubes coated in grime, too fragile to survive extraction, too dull to hold value. Many were tossed aside as waste or shattered underfoot as workers cleared their paths. Yet inside those unremarkable shells lay one of the rarest forms of mineral growth on Earth. Rhodochrosite stalactites are born not in open sunlight, but in slow, dripping darkness. For centuries, manganese-rich water falls drop by drop through the rock, each droplet leaving behind a microscopic ring of crystal over time. The rings stack, circle within circle, year after year, forming translucent bands of rose, carmine, and ember red. What appears from the outside as a dull, clay-colored tube is within a geological heartbeat recorded layer by layer. Only when a broken section was cut open did the truth emerge. Concentric rings glowing like cross-sections of ancient trees, colors shifting from soft blush to deep crimson, a record of changing chemistry preserved across centuries of dripstone growth. The miners who discarded them never saw this genesis. The outer crust concealed everything, its rough texture hiding the gemstone architecture within. To recognize the beauty required slicing the stalactite, polishing an exposed face, and letting light travel through the bands like water through glass. When gemologists finally examined a clean cross-section, the mine waste became treasure. Each stalactite revealed a history of subterranean seasons, times of richer manganese, times of clearer water, times when pressure and temperature aligned to create colors no other carbonate could duplicate. But most of the earliest stalactites were already gone, crushed during extraction, thrown into tailings, or lost to the cave-ins that sealed the tunnels. Their disappearance became part of their rarity. Rhodochrosite stalactites stand as records of patient creation, a gemstone almost overlooked because its beauty lived entirely inside, waiting for a single cut to reveal the centuries hidden within its core. Ranked 11th, Libyan desert glass. Across the dunes of the Great Sand Sea, pale yellow fragments once lay scattered like shards of abandoned glass, lightweight, translucent, and overlooked by travelers who believed they were remnants of ancient fires or military debris. Some pieces were pocketed as curiosities. Most were left to sink into the shifting sands. But these fragments were not glass shaped by human hands. They were an anomaly born from an event so violent that the desert itself was briefly erased. Libyan desert glass formed when an extraterrestrial body, traveling faster than sound, hotter than any furnace, slammed into the Earth's surface. The impact flash melted the desert floor, turning sand into a lake of liquid silica. For an instant measured in fractions of a second, temperature soared beyond 1,600 degrees Celsius. Then the molten landscape cooled in silence, leaving behind glass of remarkable purity, clearer than quartz, purer than any artificial melt, and untouched by the bubbles and imperfections that plague man-made glass. Its clarity defied explanation. Its origin was a mystery, and so, for centuries, the pieces were misunderstood. Only when scientists analyzed its structure did anomalies surface. Zircon crystals transformed into high-pressure minerals, oxygen isotopes carrying extraterrestrial signatures, and silica so flawless it could not have formed under normal terrestrial conditions. These clues pointed to one conclusion. Libyan desert glass was the remnant of a cosmic collision, a material forged in an instant of catastrophe. The discarded shards suddenly carried the weight of a rare geological story. Even the ancient Egyptians recognized its uniqueness. A piece was carved into a scarab for Tutankhamun's pectoral, centuries before its true origin was understood. Yet most material discovered in the modern era had already been lost, trampled beneath migrating dunes, carried off by collectors who never knew its significance, or dismissed as simple desert debris. A gemstone almost thrown away because it resembled something ordinary? Libyan desert glass remains one of Earth's most extraordinary anomalies. A relic of a moment when the sky met the sand in a flash of impossible heat and left behind a beauty that should not exist. Ranked 10th, black opal. In the opal fields of Lightning Ridge, miners once tossed aside dark, nondescript nodules, stones so black and heavy they seemed incapable of holding light. In a world where value depended on brightness, these rough pieces were judged instantly. Too dark to glow, too dense to reveal color, too unlikely to yield anything worth cutting. Piles of them accumulated along the diggings, discarded before their stories could unfold. Yet inside those shadowed stones lived a tension unlike any other in the gem world. Black opal hides its fire behind a veil of darkness, a layer of silica so saturated with carbon-rich minerals that no surface shimmer escapes until the stone is fractured or cut. Where white opal reveals its colors easily, black opal keeps them locked deep within, waiting for the first sliver of light to strike the right plane. When one of the discarded nodules cracked open beneath a miner's boot, the truth surfaced. A flash of electric green, a line of crimson, a pool of cobalt erupting from the fracture like trapped lightning. The darkness that condemned the stone had been its greatest strength. The black body tone intensified the play of color, sharpening each spectral burst with a clarity impossible in lighter opal. But none of this could be seen from the surface, only from within. This was the source of the tension. Beauty held captive by opacity, value wrapped in disguise, fire hidden behind a shell of shadow. As cutters learned to read the weight and shape of rough black opal, the discarded stones were reclaimed. Old tailings became hunting grounds, forgotten piles turned into fortunes. Yet much of the finest material had already been lost. Broken underfoot, scattered in abandoned trenches, mistaken for worthless ironstone. Black opal is a gemstone defined by contradiction, a stone that appears lifeless until it is opened, a treasure dismissed because it hides its brilliance too well, a reminder that some of Earth's brightest colors reside inside its darkest shells. Ranked 9th, imperial topaz. In the river-worn hills of Ouro Preto, miners once gathered pale orange crystals they believed were ordinary quartz, stones with a faint sunset hue, but none of the fire associated with prized gemstones. These pieces were tossed into wooden crates, used as markers along mining paths, or sold in bulk as decorative mineral fragments. What they dismissed carried the legacy of a geological lineage older than the mountain that held it. Imperial topaz forms in pockets of fluorine-rich vapor, rising through fractures in volcanic rock. An environment rare enough that only a handful of locations on Earth ever produced it. Within these cavities, aluminum silicate interacted with fluorine under shifting pressures, giving rise to a spectrum of colors that mirrored the changing temperature of the rising gas. Pale champagne, deep apricot, and the fiery imperial red once reserved for royalty in the Russian court. The early miners, unfamiliar with its subtle glow, saw only muted tones. They overlooked the way light traveled through its crystal channels, how thin pleochroic transitions layered warmth into the stone, how centuries of mineral evolution were captured in a single beam of color. It wasn't until a polished fragment caught the eye of a gem dealer, its interior lit with a soft, regal flame, that the stone's identity was revealed. Tests confirmed what the landscape had always known. This was not quartz nor citrine, but a gemstone tied to a rare geochemical moment. With recognition came a shift in value. Old crates were reopened. Forgotten riverbeds were searched again. Rough pieces once thrown into waterways or used as weights in mining tents became coveted artifacts of a mineral tradition shared by Brazil and the Russian imperial workshops of the past. But much of their earliest material was already gone, worn smooth by river currents, crushed under the wheels of mining carts, or lost to the ignorance of early extraction. Imperial topaz endures as a testament to legacy. A gemstone shaped by ancient volcanic breathing, overlooked because its power lay not in intensity, but in the quiet ancestral fire held within its core. Ranked 8th, star sapphire. In the gravel beds of Sri Lankan and Burmese sapphire fields, rough stones with dull, cloudy skins were once pushed aside. Pebbles judged too lifeless to carry color, too opaque to cut, too stubborn in texture to warrant attention. Among them were rounded, grayish nodules streaked with pale lines that miners mistook for flaws. These pieces were tossed into wash channels or left piled beside sluice troughs. Yet those faint, chalky lines were not fractures. They were geometry inside each overlooked nodule, microscopic needles of rutile, titanium dioxide arranged in tight, ordered bundles, crossed one another with near-perfect angular precision. 3 sets of needles, each separated by 60 degrees, formed a crystallographic map only visible when light struck at the exact orientation needed for the phenomenon to awaken. When that happened, the stone revealed a secret, a 6-rayed star sliding across its surface, sharp enough to feel carved, bright enough to cut through its opaque body. This asterism does not form through randomness. It demands precision, temperature stable enough for rutile to align, cooling slow enough for the needles to grow, pressure steady enough to keep the crystal lattice from fracturing as the inclusions set any deviation, and the star never appears. For decades, miners discarded these stones because the star remained hidden in their rough form, buried beneath a matte exterior. Only when one such nodule was accidentally polished along a curved cabochon surface did the alignment finally reveal itself. A perfect star igniting under a single beam of light. From that moment, the fate of the once discarded stones changed. Cutters returned to the piles of rough they had ignored, turning over each dull pebble in search of the faint intersecting lines they had once mistaken for imperfections. But many of the earliest star sapphires were already gone, crushed underfoot, thrown into tailings, or ground smooth in the riverbeds. Star sapphire remains a gemstone defined by precision so exact that its beauty exists only at the intersection of structure, orientation, and light. A stone nearly cast aside because it appeared opaque, yet capable of revealing a star drawn by the earth itself. Ranked 7th, chrome diopside. In the chrome-rich tundra of Siberia and the gem fields of Pakistan, miners once brushed aside sharp green shards that glinted only faintly through a film of dust. To them, these fragments looked like broken bottle glass, too vivid, too brittle, too cheap in appearance to deserve a second glance. They fell from sorting tables into gravel heaps, indistinguishable from the debris surrounding them. Yet inside these discarded pieces was a revelation of pure elemental color. Chrome diopside derives its intensity from chromium, the same element that gives emerald its fire. But unlike emerald, which fractures under the pressure of its own clarity, diopside grows in tight monoclinic chains, allowing chromium's green to rise through the lattice with unfiltered force. The result is a hue so concentrated it appears almost liquid, as though a drop of untouched forest light had crystallized within the stone. The miners who overlooked it saw only its softness. Diopside cleaves easily, and rough pieces often appear pitted or uneven. What they considered defects were the very signs of its origin. Rapid cooling in metamorphic belts, borosilicate fluids under unusual pressure, chromium captured in the exact moment the lattice formed. When a lapidary unexpectedly cut through a rough, the revelation came quickly. A green brighter than peridot, cleaner than most emerald, reflecting with a clarity that seemed to ignore the stone's modest beginnings. Suddenly, the fragments once mistaken for glass became gemstones of extraordinary chromatic purity. Collectors sought the finest shades, deep pine, vivid spring, saturated rainforest, colors that could not be replicated in other minerals without losing transparency. But much of the early material was lost before its value was recognized. Stones crushed under machinery, shards swept into waste piles, pieces pocketed as curiosities and forgotten in the cold. Chrome diopside remains a gemstone defined by revelation, a mineral whose simple exterior masks a green so elemental, so sharply alive, that it transforms the moment light enters it. A stone almost thrown away because its brilliance hid behind a thin film of earth, waiting only for the first cut to reveal the true intensity inside. Ranked 6th, purple labradorite. In the feldspar quarries of Madagascar and Finland, miners once cast aside pale gray slabs of labradorite, stones that showed no trace of the blue or gold flashes the trade expected. They were too dull, too flat, too silent under the sun. To sorting crews, these pieces were simply failed labradorite, destined for decorative tile or crushed stone. Yet hidden inside the muted surfaces was an anomaly the Earth rarely allows. Purple labradorite, sometimes called spectralite violet, emerges only when the crystal lattice bends light through microscopic layers of exsolved minerals arranged in sudden, unpredictable harmonies. Most labradorite refracts in blues and greens, the familiar aurora of feldspar, but under an exceptionally rare combination of cooling rate, structural tension, and trace elemental balance, the spectrum shifts. Red wavelengths, normally absorbed, suddenly break free. Blue wavelengths bend toward violet, and the stone ignites with a flash of amethyst fire unlike anything seen in the plagioclase family. To the miners who tossed these slabs aside, the purple remained buried beneath rough skin, its anomaly visible only when a fracture occurred at the exact angle needed to expose the internal layers. Some of the earliest pieces were discovered only because machinery broke them in half, revealing a sudden violet blaze where none had been expected. The phenomenon was so rare that even experienced cutters doubted what they saw. A labradorite that shifted from silver to lavender, from violet to indigo, from deep plum to electric rose, all within a single tilt of the stone. Once the truth spread, old waste piles were re-examined. Miners searched the discarded slabs for the faintest hint of internal color, but most of the original material had already been lost, ground into aggregate, sold as architecture stone, or left buried where it fell. Purple labradorite remains one of the feldspar family's greatest anomalies, a mineral that defies its own nature, a crystal that bends the rules of its species to reveal colors it was never expected to hold. A gemstone almost thrown away because it hid the impossible beneath a ranked fifth, painite. In the ruby gravels of Myanmar, miners once sifted through dark, hexagonal crystals they believed were low-grade spinel, pieces too opaque, too brownish-red, too unremarkable to keep. The stones were pushed aside, sold in bulk by weight, or used as training rough for novice cutters. No one suspected that these overlooked fragments would become the center of one of the greatest gem obsessions of the modern era. Painite was hiding in plain sight. Chemically, it mimicked nothing familiar. A barat fused with zirconium and vanadium, formed under temperatures and pressures rarely found in the upper crust. Its lattice carried spectral lines unlike spinel, unlike garnet, unlike any known kingdom of stones. The clues were there: hexagonal outlines, deep reddish-brown flashes under tungsten light, but too subtle for miners expecting the bold clarity of ruby. For decades, the world believed there were only two confirmed crystals in existence, two stones that slipped through the hands of countless miners, countless dealers, countless markets, both originally misidentified, both nearly lost among parcels of mixed rough. Once its identity was finally defined, obsession began. Collectors searched old drawers, forgotten lot boxes, and dusty envelopes where brown spinel had been stored for decades. Dealers emptied safes, hoping a single neglected crystal might match the spectral fingerprint of the original pair. Every small, misshapen piece was tested, every reddish shard was reconsidered, and in that frenzy, the truth surfaced. Many early painites had already vanished, cut into tiny calibration stones, traded for a few dollars, or discarded entirely. The rarest pieces were those no one had recognized in time. When new deposits were eventually discovered, the global chase only deepened. Even the finest crystals seemed to glow from within, a muted ember red that hinted at the violence of their birth. Cut stones remained microscopic, clean specimens nearly impossible, and festival material so rare that each gem became an artifact of the search itself. Painite is not merely a rare mineral. It is a symbol of what happens when the world overlooks something extraordinary. A stone so uncommon that it rewrote record books, yet so ordinary in appearance that it blended into gravel for half a century. A gemstone almost thrown away became an obsession, proof that rarity is not always revealed by beauty, but sometimes by the persistence of those who refuse to stop looking. Ranked fourth, Paraíba tourmaline. In the dry hills of Paraíba, Brazil, miners once dug through veins of crumbling pegmatite, breaking apart chalky white rock in search of quartz and common tourmaline. Among the rubble were shards of pale, washed-out blue and green, their surfaces coated in dust, their color too faint to suggest value. These dull fragments were swept into waste piles, mixed with gravel, or left to fade under the sun. No one imagined they carried an electric color the gemstone world had never seen. Then came the revelation, unexpected, accidental, and irreversible. When a miner washed a small shard under running water, the dust dissolved, and a sudden flash pierced through the stone. A glow not of color but of luminosity, as if the crystal had been lit from within. This was not normal copper staining. It was copper inside the lattice, threads of cupric ions that turned light into neon, bending it with an intensity no other tourmaline could replicate. The gem did not simply appear blue, it appeared alive. Under proper illumination, the faint rough blazed into turquoise fire, into spectral green, into a blue so radiant it seemed impossible for a naturally formed stone. The miners who had dismissed it returned to the piles they had discarded, only to realize that the most extraordinary pieces had already been lost, trampled, shattered, or buried beneath the dust of earlier extractions. Word reached dealers with the force of discovery. Stones once mistaken for low-grade squirrel rough now demanded attention. A new category was born, not tourmaline, but Paraíba, a name that would rewrite the economics of colored gems. And with recognition came competition, then scarcity, then global obsession. Old tunnels were reopened. Abandoned pits were carved deeper. Collectors fought over even the smallest fragments, driven not by size or clarity, but by the impossible glow, a color that looked less like a mineral and more like a captured Caribbean lightning bolt. But much of the earliest material was already gone, lost before anyone understood what it was. Paraíba tourmaline remains a gemstone defined by revelation, a mineral almost thrown away because its neon heart was hidden beneath a film of dust, waiting for the moment water touched its surface to reveal a blue the world had never imagined. Ranked third, moldavite. Across the fields of southern Bohemia, farmers once unearthed small bottle-green shards while plowing after the rains. The pieces were rough, pitted, and strangely light. Too light to be jade, too irregular to be glass. Children collected them as curiosities. Adults dismissed them as fragments of old bottles shattered long ago. Most were tossed aside or left to sink back into the soil. Yet every shard carried the tension of a moment. When the earth and sky collided, moldavite was born when a meteorite struck Central Europe with a force that turned the ground itself into vapor. Sand, rock, and silica were hurled into the sky, melted, stretched, and shaped by winds hotter than volcanic flame. The droplets cooled as they fell back to earth, forming natural glass unlike anything created in terrestrial furnaces. Its surface bears the scars of that violence, ripples carved by atmospheric shock waves, pits etched by explosive cooling, twisted shapes frozen in mid-flight. To those who first found it, these marks looked like imperfections. To geology, they were signatures of impact, records of a catastrophe preserved in green. But moldavite hides its identity well. It lacks the crystalline order of gemstones. Its glassy translucence seems too fragile, too ordinary. This is why early discoveries were ignored, traded for pennies, or left where they fell. Only when mineralogists identified shocked quartz and high-temperature silica within the glass did the truth surface. These were not bottle shards, not volcanic glass, but pieces of the earth flung into orbit and returned as relics of an ancient impact. And with that recognition came tension, between scarcity and demand, between geology and myth, between the quiet green stone in the soil and the cosmic violence that shaped it. Collectors searched old fields where farmers had thrown the pieces away. Villages combed riverbanks and forest floors. What had once been dismissed as debris became sought after for its extraterrestrial origin. A touchstone, to an event that reshaped an entire region nearly 15 million years ago. But much of the earliest material was already gone, lost to plows, crushed under cartwheels, or buried deeper than memory. Moldavite endures as a gemstone of tension, a relic of chaos that appears deceptively calm, a link between earth and sky mistaken for broken glass, a reminder that even the quietest stones may carry the story of an ancient impact waiting to be recognized. Second place, Alexandrite. In the emerald mines of the Ural Mountains, workers once pushed aside greenish crystals that looked too murky, too inconsistent, too confused in color to be worth keeping. To miners seeking the unmistakable green of emerald, these shifting stones appeared flawed, neither bright enough nor stable enough to satisfy the eye. Many were dropped into tailings, their dual nature hidden beneath the dust of the tunnels. But those flaws were the first signs of a gemstone defined entirely by tension. Alexandrite lives between two worlds. Its structure, beryllium aluminum oxide infused with chromium, balances on a knife edge where wavelengths of light split, shift, and even contradict one another under daylight. The stone reflects green, absorbing red as though it doesn't exist. Under firelight, everything reverses, red surges to the surface, green collapses into shadow, and the gem becomes something entirely different, a stone that changes its identity depending on the light around it. The miners who tossed it aside saw only uncertainty. The gemologists who later examined it recognized a rare optical war, the tension between two colors fighting for dominance inside the same crystal. When a discarded piece was polished in candlelight, the revelation came suddenly. The green they thought they knew dissolved into crimson. It was as if the stone had turned itself inside out. Once word spread, the same pits that had thrown the stones away were searched again, then deeper still. But the finest early Alexandrites were already gone, washed down runoff channels, crushed under ore carts, or lost in piles of emerald rejects. Even after larger deposits were found in Sri Lanka and Brazil, the tension remained the same. A gem that refuses singular identity, a mineral whose value comes from its unpredictability, a color change so dramatic it feels like a contradiction. Nature never intended Alexandrite is not merely rare. It is conflicted, a crystal forever caught between daylight and firelight, between one truth and another, between the value it nearly lost and the value it later commanded, a gemstone almost thrown away because it could not choose a single color, yet revered today because it became the embodiment of two. In first place, serendipite. No miner remembers the first piece that was thrown away. It was small, dark, something that looked like nothing, a shard pressed into the palm, then released back into the gravel. No record, no claim, no photograph, only absence. Serendipite entered the world quietly, forming in pockets so narrow that most were erased before discovery. Calcium, boron, aluminum, and silicate bound together under pressures that folded the rock until its colors hid inside midnight. Too dark to read, too dense to shine, too unfamiliar to name. For years, the stones surfaced only as shadows among waste piles. Miners chased brighter things, the brilliance of sapphire, the promise of spinel. The pieces that did not speak were left behind. Silence has no market. Even when gemologists finally recognized the structure, a lattice more complex than expected, a chemistry that should not have survived metamorphic heat, the early stones were already gone, lost to time, lost to indifference, lost to the spaces where no one looks twice. Today, the finest serendipite weighs less than a leaf. Some are thinner than a nail clipping. Others exist only as fragments sealed in museum drawers. Too small to cut, too dark to photograph, too rare to replace. Its value does not come from beauty, it comes from the silence surrounding it. A gemstone defined by what cannot be found, what cannot be repeated, what was almost discarded before anyone knew it existed. Serendipite is the final echo of a mineral that never announced itself, a relic of shadows, a survivor of neglect, a stone whose rarity is measured not by presence, but by everything that slipped away unnoticed, a gemstone almost thrown away, and in many ways still missing. Across mines, riverbeds, and forgotten sorting yards, Countless stones were lifted from the earth only to be dismissed in an instant. Too dull, too dark, too common-looking to deserve a second glance. Some were swept into waste piles. Some were crushed into gravel. Some lay untouched in the soil for decades. Yet hidden inside those ordinary fragments were colors the world had never seen, structures that should not exist, and stories powerful enough to redefine the history of gemstones. One of them, ranked #1, was nearly discarded before anyone realized that only a handful of crystals would ever be found again. This is the quiet chapter of gemology. 30 rare stones almost thrown away, not because they lacked value, but because their brilliance hid beneath dust, darkness, or misunderstanding. What you're about to see are the treasures that nearly slipped through human hands, the minerals whose beauty waited in silence for the one moment someone finally looked closer.